quest for new ideas demands passion and enthusiasm. And outstanding research results need a creative climate to thrive and develop. Take a voyage through the world of science at DLR.
Das Jahr
2010 was a great year for DLR. We experienced a great deal in all our divisions: aeronautics, spaceflight, energy and transportation, and safety. We also, above all, continued a process of introducing a new DLR-wide strategy that we initiated in 2009, and we've moved into implementation. We've held more discussions with all the DLR sites, and together we've set the course for how we can develop DLR in the future.
A vision became reality as the German-US joint project Sofia, an airborne observatory for infrared astronomy, took to the skies. The first flights were in 2009. The telescope was developed and built in Germany. Mounted in the rear part of the fuselage of a modified jumbo jet, it allows astronomers a view beyond the haze of interference caused by the Earth's atmospheric layers. Scientists expect it will provide new insight into the birth and death of stars and the formation of galaxies and planetary systems. Sofia is supported with funds provided by Germany's Federal Ministry for Economics and Technology. Air traffic controllers work at an airport, but their tower is a laboratory at the DLR site in Braunschweig. When is an air traffic controller watching what? The safety of air traffic depends last but not least on the precision with which controllers observe air traffic. They're concentrating on flight activity, just as they do in reality. Using new ways of measuring the controller's eye movements and focal points, scientists at DLR's Institute of Flight Guidance in Braunschweig are able to follow their visual activity and work with greater precision than ever before. They're searching for alternatives, designer aviation fuels. At the laboratory of the DLR Institute for Combustion Technology in Stuttgart, scientists are working on the development of alternatives to oil, perhaps to make jet fuel unnecessary. They're setting the course for the creation of environmentally friendly aviation fuels from coal, natural gas and biomass. Current results from the state-of-the-art labs in Stuttgart indicate that what are known as alternative fuels could prove superior to their conventional counterparts with respect to lower emissions and reliability. With this test rig in Stuttgart, scientists are examining a future means of providing energy, a micro-gas turbine. The test bench at the DLR Institute for Combustion Technology has comprehensive instrumentation and optical windows that allow laser-based measurement of combustion processes. Scientists at the DLR Centers of Excellence for Composites and Adaptronics are carrying out tests in a weightless environment. Realistic conditions for unfolding antennas and masts for satellites can only be simulated during parabolic flights. Here they're working with a 15-meter-long reinforced carbon fiber roll-up mast and spiral antenna for AISAT for the DLR Institute of Space Systems in Bremen. It's right on target, but from a safe distance. A laser at the research center at the DLR site in Heusen can shed light on distant risks without as much as making contact. The experiments are being done at a unique testing facility 130 meters long. These tests at the DLR Institute for Technical Physics in Stuttgart are aimed at detecting dangerous and harmful substances in actual environmental conditions. They're new ideas for the amplified beam of light. Professor Ulrich Wagner is the new member of the board responsible for energy and transport. He joined DLR in March.
Energy and transportation are significant areas, in fact key areas of any economy. Societal structures cannot function without a secure supply of energy and safe, reliable means of getting around. In the transportation sector, to me, the word future means maintaining mobility. I think that's extremely important. I don't think much of limiting scenarios, driving bans for example, or similar prospects. I would like us to be just as mobile in the future as we are today. For me, the future in terms of energy means an end to waste. Yes, it's a dream, but one we could try to get a bit closer to. And also the opportunity to use as many different energy applications as possible. We've got to rely in future on energy sources that won't run out. That means renewable sources of energy will play a key role.
The DLR Flagship is making its first appearance in new livery. The A320 ATRA Advanced Technology Research Aircraft is seen here at its new home base at the flight facility in Braunschweig. It's dedicated to pure research. A legendary name will represent a visionary program.
I name you Otto Lilienthal and wish you all a good flight.
A robot is learning to walk at the new tech lab located at DLR's facility in Oberpfaffenhofen. The Institute of Robotics and Mechatronics has developed an experimental system based on lightweight arms. Progress takes place step by step. Right now, robot Justin is walking as if on stilts, but someday these could work like real legs. At any rate, he already seems to know where to go. Right next door, they're practicing the art of simulation. A robotic arm moves off for a virtual test. The DLR Robot Motion Simulator allows a pilot to experience flying a light aircraft over the Alps. Fast rolls, vertical flight, maneuvers that put the pilot head over heels, as does a dive. The acceleration presses the pilot into the seat, just as if it were a real aircraft. A meditation room in the tech lab? What at first glance looks like modern art turns out to be a new scientific research opportunity at the Microwave and Radar Institute. New radar technologies, microwave systems and antennas can be developed here. The DLR research aircraft Falcon was alone in the skies over Europe in April on its Volcanic Ash Hunter mission. Oliver Reiterbuch of the Institute for Atmospheric Physics was among those on board. He remembers how quickly they prepared for the flight.
Normally we have 1 or 2 weeks to get an aircraft ready for a mission, but we had just 1 or 2 days. It was a fantastic experience. There were about 20 or 30 people here from Flight Operation and the Institute for Atmospheric Physics who were getting the instruments ready. They spent time assembling some of the labs, which weren't deployable to begin with, and then on Saturday or Sunday you had 20 to 30 people working away to make the first flight on Monday possible.
Falcon set course for Iceland towards the Eyjafjalla volcano.
It was really impressive. You could see it, the ash cloud from the volcano. It went up to an altitude of 4 or 5 kilometers, and then you could see it spread out over the Atlantic for hundreds of kilometers as a huge, well, it was really a cloud, an enormous cloud. The DLR flights with our Falcon led to the fact that in May and the end of April, we saw in several cases that the ash concentrations were so low that it was safe to fly again.
The mission was also a success for the pilots and technicians of the Department of Experimental Flight in Oberpfaffenhofen. There's danger ahead. Trains can't take evasive action. What happens if 2 trains approach each other on a single track? DLR is introducing a new warning system for trains. It's known as a Rail Collision Avoidance System, or RCAS, and is similar to safety systems already familiar to aviation. If 2 trains approach each other unexpectedly, a computer warns of the potential hazard and sounds an alarm. The special thing about this system is that RCAS can warn trains independently of safety technology located along the route. DLR put in a high-flying appearance at the main international event for the aviation and aerospace industry, the 2010 ILA. At this year's exhibition, DLR presented a large portion of its research fleet. The fascination of aviation graced the skies above Berlin. The hydrogen-powered glider Antares was presented at the ILA for the first time. DLR also displayed its expertise with high-tech developments in aviation and aerospace research.
Very good.
New contracts were signed. Among them were deals involving Russia, Kazakhstan, and the European Space Agency.
We better look to each other, usually.
NASA also showed great interest. Laurie Garver was among those in the Spaceflight exhibition hall who wanted a closer look. It's time to get out of the classroom and into the lab. DLR's school lab program is in its 10th year. The first school lab was set up in Göttingen. Today it's one of 9 such facilities aimed at presenting the fascination of research to up-and-coming young scientists. Whirlwinds, dry ice and soap bubbles are all part of the show. Since its inception, some 30,000 school pupils have visited the school lab in Göttingen. The launch date was June the 21st at Baikonur. The German radar satellite Tandem X was launched from the Kazakh steppes. Then Tandem X was on its way to its twin, Terrasar X, which was launched in 2007. In the next 3 years, the two satellites will work together to create a digital elevation model of the Earth's surface. DLR Space Flight Management, the German Remote Sensing Data Center, and the DLR Institute for Remote Sensing Methods and for High-Frequency Technologies and Radar Systems are all taking part in the mission. The German Space Flight Control Center in Oberpfaffenhofen is keeping the paired satellites on course. The orbiting craft have a view of more than 150 million square kilometers of the Earth's surface. They're getting the globe's measurements in 3D. The first fascinating images taken by the twin satellites feature unprecedented precision. With the pair, Germany has a data-gathering product that's unique the world over. No other satellites have ever taken such a detailed look at the Earth. It's always hot, and sometimes there's pressure. How can heat best be stored? And how can it be kept for longer periods of time? Researchers at the Institute for Technical Thermodynamics in Stuttgart are currently testing various storage ideas and operating methods with materials such as ceramic or stone. Hot Reg is a solid storage unit that's 5 meters tall. An unparalleled research facility, it's used with hot air at varying levels of pressure. Because without finding new ways of storing energy, the future use of renewable energy will hardly be achievable. A satellite is being fitted for a cloak. It's a golden protective mantle to protect it from dangers in space. The prototype satellite is known as Tete. It makes new technologies fit for use in terrestrial orbit. Technical devices for future satellites can be carried aboard this technology testing platform to first prove they work. Tete was developed in Berlin on the basis of DLR's Bird satellite. DLR Space Flight Management in Bonn supported the project, which was realized in cooperation with the DLR Department of Optical Information Systems in Berlin, the precision engineering firm Astro- und Feinwerktechnik Adlershof, and the Kaiser Trader Company of Munich. It's ready for deployment in space. The floating car is the latest thing on Berlin's streets. They're taxis that gather data on and warn of traffic jams. Data from their locations is transmitted to the traffic tower Berlin-Adlershof at the Institute of Transportation Systems. Smart mobility eases life on the move by making the streets safer and traffic more flowing. That demands foresight in traffic management, meaning focused coordination of mobile and immobile monitoring stations. It provides precise analysis of the situation on the streets that's always reliable and up to date. DLR is active all around the world. On August the 10th, DLR opened its first satellite ground reception station located north of the Arctic Circle, at Inuvik in Canada's Northwest Territories province. The German satellite Tandem X has a polar orbit, and the site offers some of the best possible reception for its signals. Scientists and other users from all over the world, in addition to those from the partner countries Germany and Canada, can use the antenna with a diameter of 13 meters to gather key data from satellites. It's a joint project between DLR Space Operations and the German Remote Sensing Data Center DFD. Chef X, or Sharp Edge Flight Experiment, is all DLR. The experimental spacecraft features an edgy angular design. It's a new technology for meeting the challenges of re-entry into the Earth's atmosphere. Furthermore, Chef X2 will involve the first test of a heat shield with active cooling during actual re-entry. Nearly all of DLR cooperated to create the craft. Developed and built in Stuttgart, the payload instrumentation is from Cologne. Tested in Göttingen in a wind tunnel, blasting shock waves at 12,000 kilometers an hour. The experiments were designed in Bremen. The flight control system comes from Braunschweig, and Chef X will be mounted onto a rocket at Oberpfaffenhofen. The launch is planned for 2011 in Woomera, Australia. A catapult is used to generate speeds of 400 kilometers an hour. A model train races through the new tunnel simulation facility at DLR Göttingen. There's no other place like it in the world. The train took just 0.6 of a second to reach the end of the 60-meter-long stretch. At the Institute of Aerodynamics and Flow Technology, researchers can now assess the handling behavior of high-speed trains when they enter tunnels and the risks that forces and pressures from side winds pose for a train. The facility makes Göttingen the most significant European research site investigating the aerodynamics of railway vehicles. This research is dedicated to railways of the future. At the world's biggest international transportation technology trade show, the InnoTrans in Berlin, DLR presented a cross-section of its ongoing transportation research projects. DLR introduced its answers to the challenges of railways in the future. Up to now, cowling, called crash elements, are used to cover the front end of trains to protect them in the event of a collision. At InnoTrans, DLR exhibited a fiberglass reinforced nose for a locomotive that's not only a crash element, but also ensures that the structure of the vehicle behind it remains free of damage. It's almost a touch and go, just 40 meters before landing. The aircraft does it once, twice, until finally it completes 13 approaches. Aircraft landings are still noisy. In cooperation with Air Berlin, Fraport, and Germany's air traffic control organization Deutsche Flugsicherung, scientists on the ground at the DLR Institute for Flight Guidance are using the research airport at Braunschweig to measure and record the noise emissions of a Boeing 737. They'll use the results to develop proposals for making aircraft approaches and landings quieter. The research serves the interests of anyone living near a major airport. The Earth Observation Center, or EOC, is a new building in Oberpfaffenhofen. It's Germany's main facility for observing the Earth. At the EOC Service Lab, information from observations of the atmosphere, the environment, and natural disasters are collated. Whether it's an earthquake, flood, or forest fire, the scientists follow current developments around the globe as they occur. One aim is to provide better support for international rescue efforts. The degree of devastation often only becomes apparent after their assessments. Early warning systems are also developed and tested here. After 8 years at DLR, Professor Joachim Sodruch bid farewell to the organization. A historical setting was chosen for colleagues to show their appreciation for Professor Sodruch. The German Technology Museum, the Deutsches Technikmuseum in Berlin.
Danke, Herr Sodruch. Das C fehlt noch, das C fehlt noch.
He's turned over the job as board member responsible for aeronautics to Professor Rolf Henke. Sodruch took the opportunity to look back.
Auf eine spannende Zeit.
It was a really exciting time that I wouldn't want to have missed. I had really great colleagues, and I can look back on technologies that we developed worldwide in an outstanding way during the last 8 years at both a national and European level.
And what are Professor Henke's plans for the future?
The bar's set quite high, you simply can't jump over it, you have to find your own way. I'm going to try to do that. What he said with respect to DLR's reputation and capabilities, I'd like to expand those and keep going on the same course, and naturally discover new places while doing it.
What does Professor Sodruch remember as the greatest moment in his career?
I'd say when the A320 flew in. It's the sum total of many highlights that were incorporated into this symbolic aircraft. When it landed at the Braunschweig airport, we could say now we're the proud owners, not just of an airplane, but the entire team and talents that are behind it. Worldwide, it's unique.
Weltweit einmalig.
The Vinci engine for Europe's successful Ariane 5 rocket is on a testbed at Heusen. Painstaking preparations are being made for a test run. Later on, the upper stage engine must be able to fire frequently in space in order to position several satellites in different orbits.
Achtung, Achtung! 1 Minuten Spannung, Prüfstand P4. Achtung, Achtung! 1 Minuten Spannung, Prüfstand P4.
At the headquarters of the DLR Institute for Space Propulsion, researchers were on tenterhooks. Heusen is the only facility for testing cryogenic upper stage rocket engines in Europe. There were just seconds to go.
10 Sekunden bis Zündung Vinci.
And then it was clear, as ignition occurred and the engine began working, for everyone far and wide to see and hear. Time for a big round of applause for successful projects and missions, as well as for passion and vision.